Hello and welcome back to astronomy. And today we're starting with our next major topic, which is stars. And we're going to be starting with our perspective on stars. So we will talk about what goes on inside a star, how they live and die, the sorts of corpses that they leave behind, like white dwarfs and black holes, and all that cool stuff. But first, we're going to set the stage by talking about what we see in the night sky when we actually just look at stars and how they move and why. So this is very, very fundamental sort of astronomy. We'll get to the physics of it later on. So to begin with, most of what we see in terms of stellar changes in the sky has to do with the day-to-day changes. So we will look a little later on at how stars change during like month to month over the course of a year. But for starters, the most obvious thing is how they change during a day or even during a few hours. If you stay outside over a few hours in the dark and you watch the stars move, that's happening because of Earth's rotation on its axis. All right, obviously, the fact that we're orbiting the sun is a much slower process. You're not going to notice that happening over the course of a single night, but you will notice the stars moving because the Earth is rotating. And it is the Earth rotating, of course, not the stars, but from our perspective, it sure looks like it's the stars themselves that are moving while we sit still. So obviously, Earth rotates once every 24 hours. So that is going to affect our view. Things will come back to where they were more or less 24 hours after, right, you start watching. But where we are on Earth also has a big impact. All right, if you just look at the rotating globe, you can imagine that if you're sitting on the top of the globe, you can see some stars that are very different from the stars you can see if you're sitting on the bottom of the globe. So in order to define where things are, we define something called the celestial sphere. And the celestial sphere is basically the night sky mapped out into a sphere around the world. The Earth is at the center of the sphere, so it's basically the screen that we're looking at around us. All right. So here's the Earth. The celestial sphere would be the stars painted on this sphere surrounding the Earth. Make no mistake, there was a time in history where people did kind of think that the Earth was sitting at the center of a sphere, enclosed in this velvety background, and there were holes poked in the velvet, allowing heavenly light to pour through, that they called the stars. We know that that is not quite true. The celestial sphere is a simple fact that we don't have depth perception in the night sky. So while all stars are actually at very different distances from us, we can't eyeball that. In fact, it's very hard to identify stellar distances. So to us, everything in the night sky looks like it's pretty much at the same distance, the celestial sphere, right? So the celestial sphere, right, it looks like all the stars are painted on this sphere, all at the same distance from us. We know that's not true. For the purposes of today, while we talk about how the stars look and how they move from our perspective, we can pretend like they're painted on the celestial sphere, just like people thought thousands of years ago. As we get to later classes and we discuss stars more as actual physical objects in deep space, then the celestial sphere certainly is less valuable. But from our perspective on Earth, it's fine enough to pretend that they're painted on a globe around us. Right? So we do define certain spots on the celestial sphere that are worthwhile to consider. The Earth's rotation axis, sticking out the Earth's north and south pole, that projects up and down onto the celestial sphere to define the north celestial pole and the south celestial pole. So if you were having dinner with Santa Claus at the North Pole and looked straight up, you would see directly overhead the north celestial pole. If you were on the equator, on the other hand, the north celestial pole would be, let's see, it would actually be on your horizon. All right. So it depends where you are, how you see the north celestial pole, but it is directly over the north pole of the world, is the point. Similarly, we define the celestial equator as sort of the projection outwards of the Earth's equator. Okay, so the poles define the celestial poles, and the equator defines the celestial equator. What we see, again, just like I said, if you're at the North Pole versus if you're at the equator, you have a very different view. So your local sky, this is a picture of your local sky, is related to the celestial sphere, but it's more complicated than you might think. So your local sky, here you are standing somewhere. Your horizon defines, well, I mean, look around you right now. there's a horizon. You cannot look below the ground, turns out, unless you've got your Superman X-ray vision going. So the horizon is the ground level. The point directly over your head is called the zenith, okay, your zenith point. And it's tempting to think of what's at the zenith point, but realistically, look straight up right now. Look straight over your head. I don't mean look up. I mean look straight, directly over top of you. It's actually hard to look straight up. So you will never really look at your zenith point. A lot of people get confused about that. They see something high in the sky and they're like, it's directly overhead. It's like, no, you pretty much have to twist your neck to look directly overhead, okay? But anyway, that's your zenith point. On your horizon, we also see some important points: north, east, south, and west. All right, if you're looking north, then west is to your left, east is to your right, and south is behind you if you're looking north. And keep in mind, north is a point on your horizon, okay? North is a point on your horizon from your perspective. It's not in the sky. It's definitely not your zenith. North is a point on your horizon, just like all of these compass points are on your horizon somewhere. So if I say a star is to the north, that means look to the north on your horizon and then look up. How high up? So here this person is pointing to the southeast is the direction they're looking, and they're looking 60 degrees up in the sky, which is actually relative. That's called the altitude. They're looking up to an altitude of 60 degrees, and that's actually relatively high in the local sky. All right? So the half of the celestial sphere that we see, and in Toronto, we're not seeing the northern half of the celestial sphere. We're seeing just some half of the celestial sphere, and that's a bowl shape, our local sky. And so it depends where you are on Earth, but it also depends what you're seeing in your local sky, depends on Earth's rotation. It depends on the time of day, and again, where you are on Earth. All right, so defining what exactly will be in your local sky when is very complicated. You need to know where you are on Earth and what time it is. And we're not going to dive quite all the way deep into that. All right. The horizon is the important issue. Okay. The horizon is the plane that separates the Earth from the sky. Okay. And it's also the plane where you find the compass points. So let's see. The tilt of the Earth, in case you didn't know, the Earth is tilted. It is tilted to about 23.5 degrees compared to the plane of the solar system. It's this tilt that actually gives us our seasons. Because the sun here, so the Earth is tilted, right, compared to this vertical line. The sun would be somewhere on the horizontal plane here, but the Earth is tilted. So sometimes the north celestial pole points more towards the sun. Sometimes it points more away from the sun. And that's actually what defines summer and winter. All right? So that's important through the year. But it also means that the celestial equator is not the path that the sun is traveling on. All right? So the celestial sphere is tilted because our north pole points to the north celestial pole. The celestial sphere is tilted about 23.5 degrees compared to the vertical of the solar system. Okay, so how are things actually moving as we spin? So here we see the Earth spinning within the celestial sphere. And the red line is actually the path the sun follows, and you can see it's tilted because the Earth is technically tilted, but it doesn't really matter which way you want to put it. You can say that Earth is vertical and the sun is on a tilted path, or you can say the sun is, on a flat path and the Earth is tilted. It's just a matter of perspective, but it can be confusing. Anyway, so as the Earth spins, what it means is that the Earth is spinning this way. So from our perspective, all the stars are moving the other way. All right. So as Earth rotates, it carries the stars around. So since we're spinning this way, right, a star will appear to move from our perspective the other way around. And so the sky appears to rotate around, and notice this, all these stars are spinning around the north celestial pole. So just like the Earth is, if you've ever seen like a globe of the Earth sitting in a classroom and it's rotating on this rod stuck through it, and the rod defines our poles. Well, so the stars are rotating around the same poles. From our perspective, they will seem to swing around the north or south celestial poles. In Canada, we're more concerned with the north celestial pole because in case you didn't know, we're in the north. And the north remembers. So anyway, we've got as well our orbital motion. So our orbital motion is going around the sun. And we're going to talk a little bit more. We'll come back to the Earth's daily motion. That's our more important point for now. But we are rotating around the sun on an orbit, and our orbital plane is the plane of the solar system, and all the planets basically orbit on almost the exact same plane. But here's the tilt, right? There's the tilt. Our axis is tilted compared to the plane of the solar system. So from our perspective, as we go around the sun, our perspective is the sun is going around us. And historically, people, had big fights over this and could not understand the difference. And it wasn't clear, are we going around the sun or is the sun going around us? As we came to learn more about planets, we learned, of course, that the sun is not going around us. We're going around it, just like all the other planets are going around it. But from our perspective on Earth, yeah, it sure looks like the sun is going around us. And notice, again, here we go, the north celestial pole, and here we see our equator. And the celestial equator would be there. The sun's path is not along the equator. It's on a tilted path compared to the equator that we call the ecliptic. And you can follow this link for a little bit more detail. So the motion of the stars, well, we are not at the North Pole. We are not on the equator. We are not in the southern hemisphere. We are somewhere close to about 45 degrees latitude, all right? 45 degrees up from the Earth's equator. So here, let's see our wonderful little doodle. So here's the equator. We're looking to the side. Okay, so we're looking, there's the North Pole, there's the South Pole, there's the equator. So Santa's up there. And 45 degrees up from the equator, roughly, is about halfway up from the equator. So here you are, and you're standing over here in Toronto, roughly. I think we're at like 42 degrees latitude, but whatever. And now think about what we actually see. Our horizon is going to be perpendicular to this line. Our horizon is going to be a tangent to the circle here. Our northern horizon is pointing to the North Pole. We can't see around the curve of the Earth. So actually our northern horizon is just pointing this way. That means our southern horizon points down this way. West is coming out of the screen right now, and east is going into the screen. Okay, so that's our local sky. Is going to be this part, right? So if you look at your zenith directly over your head is actually looking out into space in this direction. Where do you see the North Star? The North Star sits over our North Pole, way, way up, way off screen. So you can just look on a line parallel to that. And the North Star, you might think it's going to be on your northern horizon, but it's not. The North Star, parallel to this line, the North Star is up there. Okay, it's actually going to be, it's the same angle. It's going to be 45 degrees off from the northern horizon. The altitude of the North Star is the same as our latitude, depending on where you are on Earth. All right. So let's look at how things are moving a little bit more. Okay, let's say so imagine there are only 5 stars visible on the celestial sphere right now. All right, and we're looking off. This is our this is our local sky. Okay, we cannot see anything below the horizon, so all this is below the ground. You can't see it. Here you're standing. You're looking off to the north, there, to the south, and remember, north is a point on your horizon. It's not in the sky. North is not in the sky where the North Star is. You can walk north, right? You don't have to grow wings and fly to get to the north in the sky. You can walk to the north. North is on the horizon. But over the north on the horizon is somewhere where we find the North Star. So let's see. Here we see a star, another star, another star, another star on the celestial sphere. All right, North Celestial Pole is this way, South Celestial Pole is this way, and this is pretty much our view from Toronto. So we're starting with these 5 stars in the sky. Okay, that's our horizon. So this is defining our local sky. So given that this is our local sky, and we're standing here looking to the north, right? From our location, how many stars are actually visible right now? How many of these 5 stars are actually visible right now, of these 5 that are indicated? Only one of them is above the horizon. Only one star. Which star? This one. Right? This star is above the horizon. It's the only one above the horizon. The other stars we can't see right now. All right? We can see plenty of other stars all over the night sky, but of these 5, this star is the only one that's visible right now. The others are below the horizon, and you cannot see through the ground. But as things rotate, notice that things are going to swing around. So as the Earth rotates, this is 6 hours later. Okay, so right now, these stars are all on this line. Okay, north to south. So celestial pole anyway. 6 hours later, they've gone, well, you tell me, after 6 hours, the Earth has made how much of a turn on its axis? Full turn? Half turn? Full turn is 24 hours. So after 6 hours, the Earth has made a quarter turn on its axis. So a star that started here has come around a quarter of the way, and now it's over there. Can we still see it? Yes, it's above our horizon. In fact, it has gone higher in the sky. And it has also moved a little bit to the east. So it's now northeast and higher in the sky. How many stars can we see now? So we can still see this one. Now we can see this one. And the third star is on our horizon. We probably couldn't see it. All right. So now we can see 2 stars of the 5 above the horizon. After 12 hours, we've now gone halfway. So a star that started here has gone all the way up to here. It's almost overhead. It's not quite overhead, right? Overhead would be, I don't know, somewhere here. That's your zenith point. But it has gotten close. How many of the stars can we see now of the original 5? So this one is still visible. This one that we started seeing a little while ago is still visible. And now 2 more are visible. What about this one? Still below the horizon. All right? So 4 stars are now visible above the horizon. After another 6 hours, another quarter turn, the star that started off down here has gone to here, up to the top, and now it is coming back down. And now we see it in the northwest direction, fairly high in the sky, but it's still visible. At this point, actually, we're back to only 2 stars are visible. Only those 2. And this little guy over here is now back to being on the horizon. So that star actually, interestingly enough, it came up in the east. We couldn't see it at first. It came up in the east. It rose to a highest point, and then it's, which is somewhere to the southern direction, but high in the sky. Right? It rose in the east. It went up to the highest point in the south. Not at south, not on the horizon. It rose to a high point, but to the south. And now it's coming down, setting in the east, in the west. Sorry, setting in the west. And the second star, which we couldn't see originally, by the way, and is about to set again, it's actually going to set in the northwest. It rose in the northeast and is going to set in the northwest. So now, after 18 hours, we're back to 2 stars visible above the horizon only. So what about this bottom guy? We never saw it, right? And we'll never see it. As you can see, the whole path that it takes stays below the horizon the whole time. So for us in Canada, stars close to the south celestial pole, we never see. Ever. All right. After 24 hours, we're back to where we started. The Earth has made one complete rotation, and the stars are back where they started, more or less. All right. So here's a couple more links you can follow to see a little bit more of that. So if you were to actually put a camera out there and do a time lapse, right, just leave the shutter open for a while and track the stars, what you would end up seeing is what are called star trails. So here we see a picture taken over a long time, and you can see the entire path of the stars. Now, given how much of an arc these are making, so this star, for example, has moved from here to here, about how long was this picture taken for? These stars are doing about a quarter turn, maybe a bit less, but close enough, a quarter turn. So this is a 6-hour picture that someone took. 6 hours, right? Patient person. If you were to watch for 24 hours, then these stars would define a circle all the way around. What are they defining a circle around, though? What's that point? Do you remember? That point, the point that they're going around, is the North Celestial Pole. And there is a star there. Luckily for us, there happens to be a star, a bright star, very close to the North Celestial Pole. Not exactly at the North Celestial Pole. All right, this is it. So it is actually doing a little arc, but it's pretty close. I'm pretty sure this is actually Polaris in this picture. So Polaris is the North Star. We can pretend it's basically at the North Celestial Pole, but it's actually a little bit off. But it's close enough for our purposes that it's basically the point sitting almost directly at the North Celestial Pole. And so everything seems to be going around it. Polaris is actually the tail of the Little Dipper, the Little Bear, Ursa Minor. And you can find it easily enough because it is always visible. As you noticed, if I go back here, it never moves. North Celestial Pole never moves. Everything else is going around it, right? North Celestial Pole never moves, ever. And so you can always find it in the things going around it. So other stars, for example, here's the Big Dipper, a very bright constellation. So again, you can always see it because it is fairly close to the North Celestial Pole. The Big Dipper is actually not the constellation. The constellation is Ursa Major, the Great Bear. The Big Dipper is just part of the constellation. The proper name for it is an asterism. It's just a pattern of stars, not an official constellation. All right. So over time, Polaris stays more or less still, and everything else in the sky swings around it. All right. So it goes around counterclockwise. So after 6 hours, for example, the Big Dipper is going around Polaris. It never quite gets low enough to set, which is why I say you can always see the Big Dipper, and you can always see the Little Dipper. The Little Dipper is actually swinging around as if it's, as if it's tacked to the sky by its handle. So after 6 hours, they've done a quarter turn around Polaris. These here, the ends of the Big Dipper, these are called the pointer stars. And if you take that line and extend it 5 times, 1, 2, 3, 4, 5, roughly, you'll always find Polaris. So our view from Earth, it is a little tricky, right? We cannot see stars near the southern. So here's us in Toronto, and you gotta tilt your head a little bit, okay? Here's us in Toronto. Actually, this person seems to be in Europe, but who cares? Close enough. So tilt your head a little bit, all right? There's a person standing on the ground. The ground, the flat ground, is that way for them. So their horizon is this. The local sky is the part that they can see. Everything below the horizon they cannot see. And certain stars close to the South Celestial Pole, they will never see. Other stars will rise in the east and set in the west. And then stars that are closer to the North Celestial Pole will actually never set at all. And those are called circumpolar. Notice that this star is not actually all that close to the North Celestial Pole. So circumpolar does not mean close to the North Celestial Pole. It just means goes around the pole. The definition of a circumpolar star is any star that doesn't set. And this star actually is fairly far. It touches our horizon, and it goes all the way to our zenith, directly overhead. So it actually covers like half the sky. It's not that close to Polaris, but it's circumpolar because we'll never see it set. All right. So if we can see it, if it's not permanently below the horizon, and if it's not circumpolar, all the other stars, a star on this path, a star on the celestial equator, and a star on this path will rise in the east and set in the west. Southeast, southwest, true east, true west, northeast, northwest. All right. That includes the sun, the moon, and the other planets. They are not circumpolar. They are going to be rising and setting every day. So they'll come up from wherever they rose somewhere to the east. They'll come up to the southern sky somewhere. They'll reach their highest point somewhere to the south. And then they'll come down in the west. Obviously, we don't see stars during the daytime. Okay, so we're not really going to see that. They're still there, in case you didn't know, but we can't see them. It's too bright. The sun swamps them out. So here we see a picture. What time of day is this? So what I said is that things will reach their highest point to the south, right? The sun, for example, may rise in the southeast, set in the southwest. It'll reach its highest point in the south. What time is it when the sun reaches its highest point? It's about noon, right? So it's basically noon. The sun is at its highest point. For us in Toronto, by the way, the sun will never reach overhead. It'll never reach our zenith. I'm sure you've had some hot summer days where you were like, oh my God, the sun is directly overhead, beating down on you. It's not. It never reaches our zenith point in Toronto. So even at even on the hottest, longest day of summer, which is actually the first day of summer, when it reaches its highest point, it's still to the south, but very high in the sky, but not the zenith. Okay, so where will the sun be at 6 p.m.? And I mean, realistically, you should know this anyway, but quarter turn later, okay, quarter turn later, rises in the east, so quarter turn later, it'll be towards the west. So it'll be somewhere down here, all right? 12 hours after this point, it'll be below ground, and we call that night. 18 hours later, it'll be rising in the east, and then 6 p.m. it'll come back to its highest point in the south, and round we go, do-si-do. Now the circumpolar stars, those are the interesting ones, all right? So the circumpolar stars are the ones that are relatively close to the North Celestial Pole, and they never set. So this star here, according to this picture, actually does set. I don't think that's true, by the way. So this can't be Toronto, where this person is making their picture from. But in Toronto, the Big Bear and the Little Bear constellations are always circumpolar. They never set. Right? They just do big counterclockwise circles around Polaris, the North Celestial Pole. So here we see someone in Arizona. This is a nice picture, taking star trails. Where is Polaris? So from our perspective in Toronto, Polaris is about 42 degrees high in the sky. From Santa's point of view, Polaris is directly overhead at the zenith. But for someone in Arizona, Polaris is actually very, very low to the horizon. So again, the altitude of Polaris, and this is a very low altitude, it's very low to the ground, right? The altitude of Polaris is the same as your latitude. So you can always basically identify how far you are from the equator by how far Polaris is from the ground. And there are many less circumpolar stars in Arizona than there are in Canada. So it's not a property of the star. It's just our perspective. Okay, so in Arizona, only these few stars, and that is, again, that's Polaris. It's not actually at the North Celestial Pole, but it's pretty close. So only these few stars in Arizona are circumpolar, whereas in Toronto, maybe all these stars would be circumpolar. Okay, so it's simply, do they set or not? Now, let's not forget that we also go around the sun. And so over the course of a night, things change, but what about from month to month and over the course of an entire year? We are orbiting the sun. Don't forget, we can't see the stars during the day. And so if you watch this little geodesic planet here, part of the night sky is going to be blocked by the sun. And what part of the night sky? It depends where you are in our orbit. So, first off, I've mentioned constellations a few times. And many of you probably know, you've been outside, you've looked at the constellations, you know the Big Dipper. What other constellations can you name? Can you name any? Because you can. I bet you know Orion. That's a winter constellation. And I bet you can probably get pretty close to naming 12 more. So constellations are a way that people have always categorized the night sky. All right. For us in the modern world, we don't really need to know that much about the night sky. It's considered a curiosity. But for ancient peoples, they did need to know about the night sky, because if you're smart enough, you can use it to figure out the seasons. You can use it to figure out when you're going to harvest your crops, when the tides will come in, when you will basically have to live your life. So the night sky was always very important, and so people made up lots and lots of stories. Plus, they didn't have light pollution, so they could see the stars clearly every night. Kind of envious of that, if not the rest of their lives. But they could see the stars every night. They knew they were important. They defined them into patterns called constellations. So they would tell stories about, they would notice a pattern of stars in the night sky, and they would connect the dots, and they would call it. I mean, look at that. Doesn't that look like a bear to you? That looks like a bear, right? I don't know what they were smoking, but anyway, that looked like a bear to them. Okay, a bear with a super long tail. I guess bears in ancient times had really long tails. Things have changed. Anyway, so yeah, people named these patterns in different parts of the world. They named different things. In Western countries, we're more familiar with the European constellations, but certainly there are Native Canadian constellations, and there are Egyptian constellations, and there are Southern Hemisphere constellations that are completely different. But realistically, astronomers don't care about those. When we talk about constellations, and so in this class, when I talk about a constellation, I'm actually talking about a region of the sky, a defined region of the sky. Because if I want to say a star, or I've just discovered an exoplanet around a star in, how do I say? Well, I could say it's in the Ursa Major constellation, but it's not one of those stars, right? Necessarily. What if it's this dinky little star, right? Or a star that you can barely see over here. So what we do is we define the sky into patches called constellations. And the patch, of course, this would be the Ursa Major constellation. This patch of sky, anything in this patch of sky is in the Ursa Major constellation, whether or not it's in, the actual Big Dipper. There's only 6 stars in the Big Dipper, right? So we use this as sort of a graphing tool. All right. So we kind of broken up our celestial sphere into a Puzz 3D, right? Into a 3D puzzle. And these puzzle pieces, each one contains a classically well-known constellation, but these days the modern definition of a constellation is the puzzle piece itself, not just the pattern of stars, which again, a pattern of stars is called an asterism. So there are 88 puzzle pieces in our night sky. They have no physical significance whatsoever. Okay, we just arbitrarily broke it up based on the old stories that people would tell, right? Keeping in mind that constellations are really not real. The stars that make up, let's say, the Big Dipper, they are not neighbors. They are at vastly different distances from us. So if I were to fly out of the solar system, clear out to another star, and look at the night sky from a planet around some other star, they would not see the same constellations, right? Due to parallax, everything would have shifted. Things would be in different locations. They would see very, very different patterns than we would. Okay, so again, for example, from our perspective, because we don't have depth perception on the night sky, it sure looks like the stars of the Big Dipper are all really close together. A happy family? They're not. Some of the stars are relatively close, some of them are much farther away. All right? So they're not real. So they're not real, okay? And yet, historically, they have always had an appeal. People looked up at the night sky, they may have been smoking something, but they would tell stories, and they knew the patterns and what was going on in the night sky mattered to their lives. So people have told many crazy stories of what's going on out there. It's not real. Astronomy is the study of the real physics of what's going on in the sky. Astrology is the hobby of telling make-believe stories of what happens in the sky and how it affects us in a daily way. If you call me an astrologer, you're in trouble, man. Okay, I am an astrophysicist, technically is my background, but astronomer is fine. Astrologer is a non-science or pseudoscience. Okay, astrology has nothing to do with reality. It has to do with wishful thinking. So check your horoscope and make up whatever you want, okay? These stars, again, they don't affect you. They are at incredibly far distances. There is no way whatsoever, scientifically speaking, I'm not trying to be insulting, I am trying to be flat out factual. There is no way whatsoever that these things affect anything. In fact, they're wrong. So for example, classically, I am a Libra. Okay, I'm born in, well, my birthday is September 24th, so I'm a Libra. But actually, no, because do you know what? The constellations have shifted over these were defined thousands of years ago. Over the last thousands of years, like 2,500 years since these were defined, things have shifted, and technically, the sun is not in Libra, or was not in Libra when I was born at all. So technically, truthfully, the sun was in, I think, Scorpio, right? We are all told the wrong horoscope anyway. Not that you knew, because it doesn't matter. And in fact, there are not 12 horoscopes. There are actually 13 constellations that the sun passes through, because things change over thousands of years. All right. So anyway, Ophiuchus is the one, the 13th, that was not, the sun didn't pass through Ophiuchus 2,600 years ago, but it does now. So anyway, your horoscope, your astrological sign, is supposed to be the constellation the sun was in when you were born. That's wrong. They're all wrong by at least a month, because they're all wrong. But nonetheless, we can talk about, okay, what constellation does the sun appear to be in at a given time? So let's say August 21st. On August 21st, the day side of the world points towards the sun. And in the day side, on August 21st, day, the sun appears to be, on August 21st, the sun appears to be in Leo. So can we see Leo, the stars? No, because it's up in the day. The sun is literally directly in front of Leo. You definitely cannot see any of these stars on this half of the sky. So what's up at night? At night, we can see Aquarius reaching its highest point directly in the south on August 21st. On February 21st, the sun will be in Aquarius. Okay, so 6 months later, right, on February 21st, 6 months later, the sun is blocking this side of the sky, and the sun will appear to be in Aquarius. Although it's funny because Aquarius is the constellation we can definitely not see. So I don't know why ancient people chose to talk about what the sun was in, because they definitely couldn't see that constellation. But anyway, so the sun is in Aquarius on February 21st. What constellation can you see highest in the southern sky at midnight? Leo, because it's opposite the sun. So what we can see in the night sky will always be opposite the sun, right? So on March 21st, we can see Virgo highest in the sky. On April 21st, we can see Libra highest in the sky. All right. So there we go. So let's see, on September 21st, that's pretty close to my birthday. So on September 21st, yeah, I guess I'm a Virgo. The sun is in Virgo. But please don't talk to me about being a Virgo. I'm not a Virgo, I'm a human being. And do you know how you can identify my characteristics? By getting to know me. All right, characteristics are not dependent on what stars the sun blocked on the day you were born. It has no impact. I'm sorry if you love horoscopes, okay, but this is a science class, and we learn science here. Whether or not we like it, science is not about popularity. Science is about what happens. Anyway, okay, so can you tell I'm not a fan of astrology? Anyway, so yeah, so our perspective on the night sky, and notice, by the way, North celestial pole will be, Polaris is somewhere up here, way off in the far distance. So we can always see towards that. No problem. These are the stars that will be coming up in the southeast, setting in the southwest, reaching their highest point to the south. And so they will change. So here we are going around. This is the path the sun is moving along. From our perspective, the sun is moving along this red line, going through the zodiacal constellations. the zodiac constellations. Our celestial equator is at an angle to that, 23 degrees off, 23.5 degrees off. Okay, so this is the celestial equator, but the sun will be moving not along the celestial equator because we're at a tilt. The sun will be moving along the ecliptic, and the ecliptic is defined, well, it's where the sun goes and it passes through those constellations. Here's another picture. So here we go. Here's the Earth at the center of the celestial sphere. You can see the puzzle pieces, the 88 official constellation puzzle pieces that the celestial sphere is broken into. And the ecliptic is passing through here, right? The celestial equator is a very different issue. They're separated by 23.5 degrees. The Milky Way goes through here. So you can always see it to the north, especially if you're in the north. Anyway, so the Big Dipper, here we see the Big Dipper. This is at somewhat more of a southern latitude than us because it's grazing the horizon. The Big Dipper is only part of the Ursa Major constellation, the Big Bear. And again, there's the pointer stars, right? So that's Ursa Major. The Little Dipper, it's the tail of the Little Dipper where you find Polaris. Okay, and in order to find Polaris, you take those pointer stars on the end of the Big Dipper and you extend them 5 times. And you can do this, go out tonight if it's clear. You can do it any night because these are always visible. They're circumpolar from Toronto. So you can extend it, this line 5 times, right? 1, 2, 3, 4, 5. And you can find Polaris. Is Polaris north? No, it's in the sky. But Polaris sits over, oh yeah, that's fine. Polaris sits over the north on your horizon. So if you want to walk north, you walk to the point on your horizon that is directly under the North Star. So if you can find the Big Dipper, which you always can, because it's circumpolar in Toronto, unless someone has dropped you unknowingly into Australia, you can find the Big Dipper. Find the Big Dipper, use the pointer stars to find Polaris, and now you know which way north is. It's the point on your horizon directly under the North Star. Never get lost again. I hope you know what is to your north. I mean, if someone truly drops you in the woods, I don't know how much this is really going to help you, but good luck. Good luck. So anyway, if you're facing north, south is behind you, east is to your right, west is to your left. Now you know where you are, sort of, or you can at least orient yourself. Okay? Good luck. And I hope you find a Boy Scout who's somewhat more prepared, or a Girl Guide or a Girl Scout who's somewhat more prepared than you are. So the wild is dangerous. Okay, so anyway, as for constellations, what constellation is this? This is another one that you can probably name. But do you know it? That's Leo. It looks like a lion, doesn't it? What were they thinking? I don't know. Anyway, that's Leo. What constellation is it? Clear night, this one's actually going to be fairly visible. It's Cygnus, the swan. Again, man, what were they doing looking at the sky, seeing a swan? I don't know. They were creative people back then. What can I say? Here's Orion. This is a star we're going to talk a lot about. The shoulder of Orion is Betelgeuse, and it is a red supergiant, and that's going to be going supernova at some point in the next 1,000,000 years or so. This here is another spot that we're going to be talking a lot about. This is the sword of Orion. This is the belt of Orion. This is the sword of Orion. So these are his shoulders, these are his knees or whatever, and this is his sword. And that's not a star at all, that's a nebula. Turn a telescope or even some binoculars towards that nebula and you're going to see an interesting thing. We'll talk more about that eventually. So yeah, that's clearly a guy holding a club and a thing. I don't know what they were thinking. Anyway, so that's Orion. So anyway, how are we doing so far? How much time is there between when a star rises and when it sets? First question. How much time is there between when a star rises and when it sets? I bet your first thought maybe is 24 hours. No, that's how long it would take for it to go all the way back to where it started. So then maybe half, 12 hours? Is that right? But what if the star I'm talking about is Polaris? Polaris is truly a circumpolar star. It is the polar star. It never rises and sets. So the answer therefore is, how much time is there? Depends on the star. Some stars rise and set. Some stars just barely come up over the horizon and then set again. Some stars never set at all. All right. What about question 2? Stars located near where appear to move in circles as viewed from the Earth? Stars located near Polaris. They are doing counterclockwise circles around the North Celestial Pole. And Polaris is pretty much the North Celestial Pole. If you could see stars during the day, the drawing shows what the sky would look like at noon. The sun is embedded in Gemini. It's blocking Gemini. Obviously, we would not actually be able to see those stars, but imagining you could. Near what constellation would you expect the sun to be located at sunset? Leo, Cancer, Gemini, Taurus, or Aries? So if the sun is in Gemini at noon, in what constellation is it going to be at sunset? Raise your hand if you're saying Aries. And now hang your head in shame. Not really. That's most people get that wrong. Think about it again. How long does it take for the sun to go from one zodiac constellation to the next? It takes about a month, doesn't it? The stars that the sun is blocking, the only reason it moves compared to those stars at all is because of our yearly motion, our orbit around the sun. So in a few months, it'll go, from Gemini to Taurus to Aries or whatever. Actually, I think it'll go to Leo. I can't quite remember all that. But anyway, it doesn't matter. The point is, if on that given day it's in Gemini at noon, guess where it is at sunset? Still in Gemini. The stars are moving too. Due to our daily motion, the stars are rising and setting just like the sun is rising and setting. And so, of course, the entire thing is going to set. So the sun will still be in exactly the same spot in Gemini on that day. Okay? So don't forget that. Stars are obviously moving too. The daily motion of the sun is the exact same of the daily motion of the stars. If you want to see yearly motion, then it'll change to a different constellation. Okay? Or monthly motion or whatever. All right? Clear on that? That is a very common misconception. So Gemini is the answer. All right? Everything's moving. Yeah, everything's moving. Okay, and that's where we're going to stop for now. Okay? That was a lot. So it can be confusing stuff. You may have to re-listen to some of that again. You may have to follow some of the links, right? You can look up. There's lots of videos on YouTube explaining more about that stuff if you're confused, because it is kind of confusing. It's a lot to sort of shift your perspective on the night sky. Our next class is our midterm. All right. So I've already posted a little bit about this. There's descriptions of what to do. So in the content section, I have a midterm test section, and there you will find all the information and links that you need to do the midterm test. Okay, the midterm test is 30 multiple choice questions, and there is a discussion forum that I've made special for that. If you have any questions about anything coming up to the midterm test, then you can ask them there. Don't forget, obviously, that this is why we did the Q&A discussion, right? Is to already ask some questions about the previous lessons. And so hopefully you've already started your studying, and you've done that. So you've started your studying a little. If you have questions, post them in the forums. All too often, people email me questions the night before. And you know what I respond with? Same thing I always would. I say, post it on the forum and I'll answer it there. And they've run out of time to do that. So please post your questions on the forum. If you have a private question or a private issue, then you email me. All right. Study well. Make sure not to just read and reread the notes. By the second or third time you read something, you don't get anything else out of it. So make sure to do all the sort of same things you would do. Cue cards, right? Make notes, make summaries, make up your own questions, right? Make study groups with other people in the class if you can. Make up questions for them. Test each other. Test yourself. All right, and get ready for that test. And then once that test is over, when we come back, for our next lesson, we will be talking about stars as physical objects. What are they like? How do they vary? So here's Betelgeuse again, the shoulder of Orion, and it truly is a supergiant. Look at that. That's the sun. That's the size of Betelgeuse. All right. Notice the color is different. All right, the colors differ, the sizes differ. Stars are very, very interesting objects. The life and death of stars are some of the most interesting details in all of astronomy, and the corpses of stars can be some of the most interesting objects in all of space. So next class, we got our test, and the class after that, we'll talk more about those fascinating objects. But obviously what we're going to do now is our after class homework assignment. All right, so good luck with your studying, and let's get to it.